In this video, we will solve this definite integral right here, and so let's begin. Now, this is an example of an absolute value piecewise type problem. And in the description box of this video, I categorize different types of integral, but this one involves absolute value and a piecewise function. So let's kind of break this down and to show why we need to split it up. So the absolute value of x minus 1, and this is equal to, you could say if you wanted to split it, x minus 1 when x is greater than or equal to 1. And let's think about this. If x is 1, 1 minus 1 is 0. If x is 1, 1 minus 1 is 0. If x is 2, 2 minus 1 is 1. Here, 2 minus 1 is also 1. Now, this is only applying for x is greater than or equal to 1. Now, if it's less than 1, you could say negative parentheses x minus 1 when x is less than 1. Let's think about this. So a number less than 1, let's try 0. 0 minus 1 is negative 1. The absolute value of negative 1 is 1. Let's try this piece. Negative parentheses 0 minus 1. So negative parentheses negative 1, which is positive 1. And the reason we have to do it this way is the integral of an absolute value symbol, we don't know how to operate that. But when you split it up, we can operate it. So what we're going to do now is redefine our integral. So we're going to say from negative 2 to positive 1. And from this criteria, we're going to use this part of our function. Negative parentheses x minus 1, close parentheses dx, plus. Now we have to approach it from 1 all the way to 3. So from 1 to 3, we're going to use this function, parentheses x minus 1 dx. So now we can kind of clean this up a little bit. So we can say that this piece would be negative 2 to 1. That's the same. We can distribute this negative to both pieces. So we'll get a negative x plus 1 parentheses dx. And the other piece will remain the same, but I can just rewrite it. So parentheses x minus 1, close parentheses dx. So now we need to take the integral of each piece. So the integral of negative x would give us negative x raised to 2 divided by 2. And then our 1 would be just a positive x. And it's being bounded by negative 2 and 1. Now we can do this piece. So x becomes x squared divided by 2. Negative 1 becomes negative x. And it's being defined by 1 to 3. So now we can swap the values. So we put in a 1, we would get negative parentheses 1 squared divided by 2 plus 1 minus parentheses, now we do negative 2. So negative parentheses negative 2 close parentheses squared divided by 2. And then we put in a negative 2 here, close parentheses, close parentheses. And I'll do this piece in blue, so plus parentheses. So you're going to replace x with a 3. So we'll have parentheses 3 squared divided by 2 minus, put in a 3, then minus parentheses, you put in a 1, so you get parentheses 1 squared divided by 2 minus 1, close parentheses. So now we can calculate, so negative parentheses 1 squared, so 1 squared is 1, so we get 1 divided by 2 is 1/2, so we have negative 1/2. So negative 1/2 plus 1 minus parentheses, so negative 2 squared. Negative 2 times negative 2 is positive 4. You have a negative in the front, so you have negative 4 divided by 2 would give us a negative 2 minus 2, close parentheses. I'll do the other in another color, so plus parentheses. So 3 squared would give us 9. 9 divided by 2. We have a minus 3 minus parentheses. 1 squared is 1. 1 divided by 2. And then minus 1, close parentheses. So negative 1/2 plus 1 would give us positive 1/2 minus parentheses negative 2 minus 2 is negative 4, so negative 4, close parentheses, parentheses, plus 9 divided by 2 is 4.5. 4.5 minus 3 is 1.5 minus 1/2 minus 1 would give us negative 1/2. So we'll put negative 1/2, close parentheses. Okay, so 1/2 minus minus 4, so 1/2 plus 4 would give us, I can write it as 4.5 plus 1.5 minus minus 1/2, so 1.5 plus 1/2 is 2, so plus 2, and we would get 6.5. as our final answer. And that's all we need to do for this problem. Again, for more practice, check out the description box for more videos.